and I'm killing it. Like a blind man reading, I'm feeling it. Like, here comes the, here comes the, here comes the. Y'all don't really want it like that. Here comes the, here comes the, here comes the. Y'all don't really want it like that.
Hello, I'm Gaylord LEGRIS, and today we will present to you our project titled NBA Player Salaries Estimated by Regression Models. In this project, we aim to predict the salaries of NBA players based on their statistical performance on the court. To accomplish this, we utilized various regression models and artificial intelligence techniques. The NBA has strict rules regarding salary caps and luxury taxes, making it crucial for teams to effectively manage their financial resources. Our goal was to explore the feasibility and relevance of using player performance data and statistics to calculate their salaries, ultimately providing a precise tool for evaluating NBA player salaries.
Hello, I am Nino Romano and I will present to you how we worked around our dataset. We selected a set of variables that we deemed most relevant for estimating a player's quality. These variables include the number of points, assists, rebounds, steals and blocks per game, the age, and some other statistics or indicators about players' influence on the court. We collected this data from the Basketball Reference website for the 2023-2024 season and added the players' names, IDs, and salaries from the ESPN website. To create our database, we took care to avoid duplicates due to transfers during the year. We also looked at statistics from previous seasons to have more data. However, since NBA contracts can last several years, we use data from the 2003-2004 and 2013-2014 seasons, as there are not many players with very long careers. To account for the difference in salaries due to inflation and the evolution in the salary cap, we decided to adjust salaries.
Hello, my name is Mathis BLANCHOT and I will talk about the GLM section. First of all, we decided to transform the salary data using an inverse Gaussian and then apply a logarithmic function to eliminate negative parameters. This allowed us to build a more accurate model by removing any potential bias caused by negative values. After performing the regression, we found that the most significant values were age, number of matches, and points. Using these variables, we constructed our GLM on the programming language R. We validated using the chi-squared test. Our model achieved an R-squared value of 0.67, indicating that it explained 67% of the variation in the salary data. This is a reasonably good fit, but we still wanted to explore other models to see if we could improve our predictions. We also performed a residual analysis to check the assumption of the GLM. The residual plot showed that the errors were randomly distributed around 0, and there was no tree pattern in the residuals. This confirms that our model met the assumption of the GLM and was a good fit for the data.
The random forest model is a machine learning algorithm based on decision trees. A decision tree is a flowchart-like structure in which each internal node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. The tree is built by recursively partitioning the data into subsets based on the feature that best separates the data according to the target variable. Random forest improves upon decision trees by using a technique called bagging, or bootstrap aggregating. Bagging involves creating multiple subsets of the training data, feeding a decision tree to each subset, and then averaging the predictions of all the trees. This reduces the variance of the model and improves its accuracy. In addition to bagging, random forest also uses feature randomization. Instead of considering all the features when deciding how to split a node, random forest only considers a random subset of the features. This decorrelates the trees and further reduces overfitting. We applied the random forest model to our dataset using Python, and we found that random forest outperformed the GLM in predicting NBA players' salaries. Most of our residuals were within a range of $10 million, and we achieved a maximum R-squared of 0.72. This suggests that the random forest model is a powerful tool for predicting NBA player salaries.
The XGBoost model is a powerful machine learning algorithm that belongs to the family of gradient boosting algorithms. It sequentially builds a strong predictive model by combining multiple weak learners, typically decision trees. However, unlike random forest, XGBoost uses a different approach to constructing decision trees called classification and regression trees, also called carts. In carts, each tree is built by recursively partitioning the data into subsets based on the features that best separate the data according to the target variable. The tree is then pruned back to avoid overfitting, and the predictions of each tree are combined through a process called boosting. In boosting, the predictions of each tree are added together to create a final prediction. This is different from random forest, where the predictions are averaged. We applied the XGBoost model to our dataset using the programming language R. We found that it outperformed both the GLM and random forest model in predicting NBA players' salaries. Like random forest, most of our residuals were within a range of $10 million, but we achieved an average R-squared of 0.72 and a maximum R-squared of about 0.76. This suggests that the XGBoost model is also an effective tool for predicting NBA players' salaries.
In conclusion, our project aimed to predict NBA player salaries using various regression models and artificial intelligence techniques. We found that the most important statistics for predicting NBA player salaries were points, age, and the number of minutes played. Our finding could be useful for NBA teams looking to optimize their salaries and make more informed decisions regarding player contracts. We compared 3 different models and found that the XGBoost model outperformed both the GLM and random forest model. This type of project demonstrates the potential of AI models from performing regression tasks in data analysis, particularly in the insurance and actuarial fields that we are studying. Using this tool for our project allows us to gain valuable experience in topics that we may encounter in our future careers. Overall, we are excited about the possibilities that AI and the regression models offer for data analysis and prediction in our future industry. Thank you for your attention.